The standardized exam. I want to take the. No, it's called the GRE. I want to take the GRE math test, and I thought, it's algebra, so I'm not even going to bother studying because algebra. I've already had like 2 years of calculus, so I thought algebra is going to be so easy. But then I took it and I did bad. I did like 78%. And I couldn't believe it. 78%.
Passing is better than failing.
No, this 78% is the entire population, and this is the entire population includes people who haven't had calculus, the people who only had algebra, or basic algebra. It was the entire population. So 78 percentile was bad. In science, it should have been in the 90 percentile. And so,
For what, like in college?
well, I didn't think I had to study for it because it's just algebra, and I had plenty of algebra by that time. And so then I looked. After that, I couldn't understand why I did so bad, so I went and got an old, you can buy old tests for practice. I went through an old test, and then I figured out why I did so bad because I was just misled. These types of things, like, okay, I'm thinking formal charge, and I'm only thinking formal charge, but you can't. When you're asking about Lewis structure, you got to think about all factors, right?
Just tell us that next time, no?
No, well, they don't tell you either on the GRE. You can't always expect it. No, if you do take the GRE.
What does the GRE stand for?
It's the exam for graduate. It's called the Graduate Record Examination.
So everybody has to take it?
Everybody has to take it.
What?
Everybody has to take it that wants to go to graduate school.
All,
Wait, just
all
the UCLA?
on my path.
No, across the nation.
But you do because you got all this score. You have
You have to do that for an MD?
No, you have to take the MCAT for MD.
Oh, okay. I forgot. I was like, wait, you want to take my
Is this in your future? Good luck.
So, the GRE, they have subject tests and general. The general test is math, English, and no, actually just math and English. So surprising on the English, I did okay. I got in the 90 percentile in English, but for math I didn't. What's that? Yeah, you're right. It's like an SAT. So if you look at the math, this is elementary algebra, linear algebra, abstract algebra, and number theory. So all those things I covered.
Number theory was that, you know what we were talking about earlier?
Group theory?
Group?
Yeah.
What's number theory? History on that exam?
No. If you're a history major, you take the history subject test.
Because I can hear it in my kids.
Let's get back to chemistry. Yeah. So the thing is at UCLA, you know how many classes I had that had multiple choice exams?
All of them.
Only one. Yeah, there was out of a lot. A lot of classes. I took a lot of classes at UCLA. In all, I took English classes, history classes, just all kinds of classes. Film class, and there was only one class that had multiple choice.
Which one was it?
Which one was it? It was okay. If you're a physical science major, then you have to take a life science class at UCLA. So people talk there and they say, okay, what is the easiest life science class you can take at UCLA? And everybody says the easiest life science class you can take at UCLA is paleontology. So paleontology, you think, okay, how does that classify as life science? But everything's dead. It was Yeah, fossils, right. And so, yeah, I took that and it was all multiple choice. And the multiple choice questions were straightforward. But when you get hit with a GRE, they penalize you. Each wrong answer is like minus 0.2. So you can't guess. And if you do guess, you better try to make an educated guess because you get penalized for each wrong answer. If you leave it blank, you get 0. If you mark it and you took a random guess, then they want to penalize random guessing. So then it's minus 0.2. I don't know what they do now. When I took it, that's what they did. What's that? They don't know if it's random. Each wrong answer is negative. So you have to be selective in the answers that you do. So that's why I put multiple choice on my test because it's kind of a skill to get because it's easy to be tricked like I was. Do I have pets? Yeah, I do. I have 2 dogs. Yeah. All right, I'll bring the picture of this dog. They're rescue dogs, 2 rescue dogs. What's that? What breed? Okay, I don't know exactly what breed, but there's supposedly a mix of a terrier plus Chihuahua. They're small dogs, 10-pound dogs. Let me get back to this, though. Otherwise, I'll tell you the names because they get confusing with picture. I'll bring a picture. Let's talk about stoichiometry next here. The easiest thing for gases is to use volume ratio if it's possible. So here, the chemical equation has the mole ratio, 2:1:2. Since volume is directly proportional to the number of moles, V is proportional to N. We can take this as a volume ratio too. So it's a 2 to 1 to 2 volume ratio. So we can use whatever units we want, liters. So 2 liters, 1 liter, 2 liters, or gallons, 2 gallons, 1 gallon, 2 gallons. The only restriction for this is that the pressure and temperature need to be fixed. That is, when I say fixed, it's constant. So temperature and pressure are fixed or constant. Then we can do that. There is a problem though, and one of the problems is something like this. So let's do this as an example. We'll do 2H2 gas plus O2 gas yields H2, 2H2O. We're going to go with a 2H2O like that. And so here, let's say if I have 50 liters of hydrogen gas, how many liters of oxygen gas do I need? I need 25 liters of oxygen gas, and that would be stoichiometric. You know, I have twice as much hydrogen as I have oxygen, and that works. And then how many liters of H2O liquid would I form? So you go, okay, I'm going to form 50 liters of H2O liquid. Is that right?
No.
No, 75 times 2.
Well, you would think 50 plus 25 should give us 75, but it doesn't, because they react. Since they react, it's like this earlier slide that we saw here. The earlier slide, this is Avogadro's law, by the way. The earlier slide just says that the volume is going to just be proportional to the moles of particles. So here I have 8 molecules. This is going to require this volume, or 4, actually 4, sorry. Here I have 8. If I have 8 particles, even though they're a lot smaller, they require double the volume. This is for gas. So this would be, let's say, 50 milliliters of O2. 50 milliliters of O2 would require 100 milliliters of H2. Because 100 milliliters would have twice the number, so I need twice as many H2s as I do O2, although I have to flip over there. When they react, there's no more O2 and there's no more H2 left. Now we have H2Os. And so if I have 8 H2Os, it's going to require this volume here. So that would be 100 milliliters of H2O. And so it does. 50 plus 25 just goes to 50. But this is this is one of those things. You know, this is the mistake I made in the GRE math test, because I was so used to doing things a certain way. You know, since I was used to it, I just come up with an automatic answer. Okay, this plus that gives this, right? But then they put a little twist in there, and that's where I realized I made the mistake. I have to rethink these questions. I can't just automatically come up with the answer. And so this would be pretty automatic, you know, 2, 1, 2, 50, 25, 50. Except there's a big difference here. The big difference is this is a gas and this is a liquid. And so this turns out to be wrong, totally wrong. You know how many liters it makes?
25.
No, it makes 0.04 liters of H2O liquid.
Yeah, because liquid's a lot more condensed.
Yeah, the liquid's a lot more condensed. So if I take, this is, you remember the Coke can thing? If I take 50 liters of steam and condense it into a liquid, its volume is only about 40 milliliters. And so 50 liters of steam only makes 40 milliliters of liquid water.
That's why it imploded?
That's why it imploded. That's why you had a huge vacuum. And so this is the issue here. So even though this is the best, it works for gases. This is fine. This is a gas. This is a gas. It does not work for liquids here. So if we have a liquid or a solid, what can we do? Well, we can't use these volume ratios for liquids and solids because it's going to screw things up. So what we have to do is we have to use just regular stoichiometry. And so using regular stoichiometry, we have regular stoichiometry, then we have two options when dealing with gases. So option A with gases is we use the ideal gas law to solve for things. So use
PV.
ideal, yeah, PV equals nRT, gas law. Or two, or B, we use the molar volume. Use molar volume. All right, and so this is the way we'll do this particular problem here. Let's say we have 50 liters of hydrogen plus 25 liters of oxygen makes how many liters of H2O liquid? Okay, then we're going to do this. We're going to do this at room temperature and
Room temperature.
1 atmosphere. And so this is stoichiometric. So, you know, stoichiometric means there's no limiting reagent. We're going to use both reagents. Exactly. So we can either start off with hydrogen or oxygen. It doesn't matter. Which one do you want to use? Hydrogen? All right, so we're going to start off with liters of hydrogen, and it's going to be 50 liters of hydrogen. Okay, what we're going to have to do here is we're going to go from liters to moles of hydrogen. Okay, the first way we can go from liters to moles is by using the ideal gas law. N is equal to PV over RT. The second way we could go from liters to moles is by using the molar volume at room temperature and 1 atmosphere. Okay, so we're going to do both ways to get there. And so the first method, okay, we'll do the calculation here. N is equal to PV over RT. Pressure is 1 atmosphere. Volume is 50 liters. 1 atmosphere times 50 liters divided by R, which is 0.08206 liters atmosphere per mole Kelvin. And T is going to be 298 Kelvin. Okay, we take a look at the units here. Make sure the units cancel out. Atmospheres cancel, liters cancel, Kelvin cancels. And that gives me 1 over moles. So I'll invert and multiply, and I end up with moles. And so let's see how many moles of hydrogen I get here. So it's going to be 50 divided by 0.08206 divided by 298. 2.044 moles. 2.04. How many sig figs? Let's go with 2 sig figs. 2.044 moles. Okay, so this is using the ideal gas law to figure out how many moles of hydrogen I have. If I know the volume, the temperature, and the pressure, I can figure out how many moles. Okay, once I have the moles of hydrogen, then I'm going to go to moles of H2O. Yeah. And so what's the mole ratio here?
Of hydrogen to oxygen.
Yeah.
I mean hydrogen to H2O.
So what I'm going to do is I'm going to do this. I'm going to go 2.044 moles of hydrogen. And the mole ratio from the equation is this. It's 2 hydrogens plus an oxygen yields 2 waters. So it's a 1-to-1. So I'm just going to do 2 moles of H2O for every 2 moles of hydrogen.
Well, we could have done 1 over 1.
Yeah, we could have done 1 over 1, but I just leave the numbers. as is. And then what?
Then we go from moles of hot H2O.
Okay, now what we're going to do is, this is H2O liquid. And so what I'm going to do is I'm going to go from moles of H2O liquid to grams of H2O liquid. So it's 18.02 grams of H2O liquid per mole of H2O liquid. And then do you know the density of H2O liquid?
1.
It's 1. And so we're just going to call it 1 milliliter of H2O liquid weighs 1.00 grams of H2O liquid. And so what does that come out to? So I'm going to do, well, here I'll just do 1 to 1. So I'm going to skip that times 18.02. And I don't need to divide by 1. And so what I end up with is 36.84 milliliters. 36.84 milliliters of water, H2O liquid. And then I need to convert that to liters. And so how many liters is that? Well, it's going to be 0.0368 liters, or roughly 0.04 liters. So this is where I got the number. How many liters of H2O do I form? I'm going to form about 0.04 liters, or about 40 milliliters of liquid water. All right, this is the ideal gas method. The molar volume is this. Either we have the molar volume memorized. You have the molar volume at room temperature. This is the molar volume of the gas. You have the molar volume of a gas memorized for room temperature in 1 atmosphere. Yeah, you have it memorized. The molar volume is equal to 24.5 units liters per mole. And so this is 24.5. This is equal to 24.5 liters of any gas would be 1 mole of that gas. It could even be a mixture. It doesn't even have to be pure. Or we calculate it. And so either memorize. This one's useful to memorize, or calculate. If we calculate it, we use the equation for molar volume. Molar volume is equal to RT over P. And so we can plug it in. 0.08206 liters times atmosphere per mole Kelvin times T, which would be 298 Kelvin, divided by P, which is 1 atmosphere. And the units, you know, you can tell if you have the right equation, because it's hard to remember the equation sometimes. But you can tell if you have the right equation if the units work out. So the Kelvin cancels, the atmospheres cancel, and that leaves us with liters per mole. That's the correct units. And so this comes out to 24.466 liters per mole, which we can round to 24.5 liters per mole. Okay, if we use method B, then we just do one long dimensional analysis problem. And so we have to do this calculation first, and then for method B, we're going to use that as a conversion factor. And so for method B, I start off with 50 liters of hydrogen gas, like this. And then I can go straight to moles, because I know that there's, for every 1 mole of gas under this temperature and pressure, it's going to occupy 24.5 liters. And so I can just go from liters of hydrogen to moles of hydrogen gas. And then from moles of hydrogen gas, I could go to moles of water. There's 2 moles of water for every 2 moles of hydrogen gas. And then from moles of water, I can go to grams of water. There's 18.02 grams of liquid water for every mole of liquid water. And then I could go to the density. That is, there's 1 milliliter for every 1.00 grams of water. And then I can just convert it to liters. You know, converting it to liters, there'd be 1 liter per 1,000 milliliters. So let's see what this calculation gives us. It might not be exactly the same because of rounding error, but so I get 50 divided by 24.5 times 18.02 equals 36.77. So over here I got 36.84. Over here I'm going to get 36.77 milliliters. One of the reasons it's off so far is because I rounded, you know, the molar volume just to 3 sig figs. If I use more sig figs here, it'd probably be closer. So 36.77 milliliters of H2O liquid, which is going to give us about, well, to 2 sig figs, it should be about 37.037 liters, 0.037 liters. So we get the same answer as this one. All right, so that's what we have to do. And so I know the molar volume of a gas at room temperature in 1 atmosphere, but I don't know the molar volume of the gas at other temperatures and pressures. For example, I know I have it memorized. I have the molar volume of the gas memorized at STP, but do you? No, you don't. But you don't have to. You know, and since STP is kind of rare, we aren't going to bother. This is much more common. Room temperature in 1 atmosphere is much more common, so this is a lot easier to memorize. You know, and the number is, it's about 25 liters per mole. And so this is why I did, you know, 50 liters would be about 2 moles. 25 liters is about 1 mole. So 2 moles of hydrogen, 50 liters, 1 mole of oxygen, 25 liters, etc. So let's try this one out here. But that's actually time for break.